Hello there, it is Kitty the Crazy Math Nerd back for part 2 of derivative of inverse functions. So let's kind of make sure we understand what we did last time. In our first video that you may have seen, we talked about if f of x is the original with the point a, b on it, and g of x is the inverse with the point b, a on it, then the derivative of that inverse at b is 1 over the original function at a. So they are reciprocals at that point that they switch. That's pretty cool, by the way. Another way you might see this is you might see f inverse prime at b, like because that does mean the inverse of f, excuse me, is equal to 1 over the derivative at a. Okay? All right, so now this video is all about working problems. So I have given access to your teacher to see this worksheet. If you don't have it, you may pause at any time and write the problem down. All right, this problem is very cool. All right, it tells you everything about f and f prime, but then it asks you about what is the inverse's derivative at 5. Well, we know that the inverse's derivative at 5 is equal to, we just did it, 1 over the original function's derivative, not at 5. Remember, this is the x of this function, right? Which means it's the y of that function. We need the x of this function, so that would be 4 is what we're going to use. And I know this may sound weird, but I just remember things the way I can. If you're asked to find the derivative of the inverse at a value, that value is never put into the original's derivative. That helps me. Okay? So, man, wish I knew the derivative at 4. Oh, look, I do. There it is. So I'm going to do 1 over 2 over 3, and that's a complex fraction. Let's flip that and multiply, and we get 3/2. So D is our answer. So an inverse's derivative is the reciprocal of the original at the switched point. It's kind of how I think about that. Okay? All right. So I'm going to, I'll do anything in order. So we just did number 5. We are going to do number 6, and then we're going to jump around and do some more. All right. So here we go again. We know stuff about g and g prime, and then they ask us about what is the derivative of the inverse. So I'm going to write down the derivative of the inverse at 3. I'm going to write down the question, and then I'm going to write down what I know I'm going to need to get, and that is the original, not at 3, not at 3. 3 does not go here, but this is the x of that. I need to know when this function, the original, that's the y. So this is the y here for that x. That is the value that we want to find it, because the derivative of the inverse at 3 is a reciprocal of the derivative of the original at the other point when you switch them. Okay? Boy, I wish I knew that derivative at 7. Oh, look, I do. Yay! So I'm going to put that in there. And again, it's a fraction, flip and multiply, and we get 4/3. No, not every answer is going to be D, but it is on those two. Now, let's talk a little bit about what is the distracting part of this. They gave you extraneous information you did not use. Look at there. We didn't use that at all either, because they thought you might think that the inverse's derivative is 1 over g prime of 3, and you put 5/6 there. No, we know that these numbers never match in this definition. So notice that if I do 1 over 5/6, I get 6/5. Look, there's your distractor answer. And when you take an AP test, if there is a question like this, they will do this incorrectly and make that one of the answers. So be careful and don't fall into the trap. All right. Well, we're going back to 3. So if we go back to 3, let's look. Now, this is a little different in that the way it's worded is different. But if we think about what that means, that's the inverse, right? So sometimes I have to say things out in words for them to make sense to me. So the derivative of the inverse at 2. So that's the same as writing what is the derivative, what is the derivative of the inverse at 2? So I want this to kind of look like what I just saw. So sometimes I have to change things so I can relate them to things I've already done. Well, before when we did this, we said, well, the derivative, see, that's not the derivative. The inverses, there we go, derivative at 2 is equal to 1 over the original function's derivative not at 2. And so we know that there is a point on this 2 something. And that means that on the original, there's a point something 2. And we need this value. That's what we need, and that's what we're going to put in right there. So I'm thinking to myself, oh, Lord, how do I do that? Well, if you look at this, this is a y value. So I really need to know when x to the 5th plus x is equal to 2, because that's the y, and that's the y, and that's the y. And if I can find the value that makes this true, that is the value that goes right there. This is the part you're not going to like. There's not a mathematical way to really do this. You just kind of plug in numbers, and usually they're easy numbers and not hard. You just kind of plug in numbers and see which one makes sense. This one's a little easier, and that's why we started with this one, because you can kind of see if you put a 1 right there and you put a 1 right there, you do get 2, right? So I think the x value we're looking for is x equals 1. So I think, and I'm almost sure that's a 1 and that's a 1, okay? So we had to go find that value. That's what's different from the last problem that we did. That's why I started with the other ones. They were a little easier. And now I know I need to find f prime of 1. Well, again, in just a small pickle, because I don't know what f prime was. You know, let's look at that last problem. See, they told us everything we needed. I'm going to mark that out. We didn't need that at all. They told us what we needed, and we just plugged it in. Woo, that was nice. This time we're going to have to work a little harder, because I have to actually go find f prime of 1. Now, I have f, and I know how to take the derivative algebraically, so let's just do that. I ain't scared. All right, so f prime at x of x, I'm going to plug 1 in a minute, is 5x to the 4th plus 1. See, that's really an easy derivative. What was I scared about? All right, here's f prime. We're going to plug in 1, and we get 1 to the 4th is 1. 1 times 5 is 5, right? Let's put 1 there, 1 to the 4th 1. And so that is 6. So now I do have f prime of 1. So now I can say that f inverse's derivative at 2 is the reciprocal of the derivative here, which is 6. So my answer is 1/6. And there you go. All right. This isn't hard stuff. I did have to work a little harder on this, but it wasn't hard work. It's just more work. They just didn't give it to me. All right, let's try another one. Okay. Well, this kind of looks like the one we just did, except this one asked it in symbols, which I like better. So I have a function, and I'm asked to find the inverse's derivative at 3. So here I go. I'm not scared of this. Come on. So the inverse's derivative at 3 is equal to the reciprocal of the original's derivative at something, not 3. Because what we really want, if this point has the point 3, I don't know on it, then the point I don't know 3 is on the original. And this is the part that we have to plug into this derivative. Okay? So we got to figure out what that is. So again, we got to do a small little kind of guess and figure out what that value is. Because there is not a way, see, so I want to set 3 equal to 1/4 x cubed plus x minus 1, and there's not a way to do that kind of cubic. So I'm going to guess some numbers and just try to figure it out. And they're never hard numbers, so don't worry. It's not going to be anything crazy. It's normally it's not going to be anything like a half or an eighth or anything weird. It's some nice numbers. So the first thing I notice is that if I do try to use 1 right here, 1 cubed is 1 and times a fourth, that would make me dealing with fractions all in here. And I know that if I add a fraction to some other integers, that's not going to give me 3. So here's my guessing. Here's my thinking cloud. So if x equals 1, that doesn't work. I know that that doesn't work because I'd get some fraction. I don't know what it is, but it's not 3. So I go to the next easiest number, and that's 2. And what's nice about 2 is that 2 cubed is 8 and is divisible by 4. So I'm just going to try that and see what happens. So my next thinking is, let's think about x equals 2. So if I plug in 2, I get a fourth of 8 plus 2 minus 1. And a fourth of 8 is 2 plus 2 minus 1. Oh my goodness, we have found it. It does equal. So that is the number that we're looking for. But I did have to kind of guess a little bit. That was not, I just didn't, and I didn't just make it up. I just guessed easy numbers just until I found one that worked. So 2 is our magic x that we're actually looking for. So I need f prime of 2. Guess what? I don't have f prime of 2. So I have to actually take this derivative algebraically and plug in 2. And again, guys, that's not hard, right? We're not scared of this. Come on. So f prime of x is equal to 3/4 x squared plus 1. So that's not hard. And I'm going to plug in 2 because I want f prime of 2. So f prime of 2 is 3/4 times 2 squared plus 1. Oh, look how sweet that is right there. Love it. Because 2 squared is 4, so they're going to cancel, and 3 plus 1 is 4, right? Oh, love this. So our answer is the inverse's derivative at 3 is equal to 1 over f prime of 2 is 4, and that is C. Oh, man, this is getting easy, isn't it? I know. So this is kind of tough because you have to kind of guess and check to find the x, but it's still not hard. They're not going to give you hard numbers. All right, this is cool. This is a table problem. This is number 10, so if you'll find that one for me. And in this problem, they tell you that h of x is the inverse of f. So you have, I'm going to write it. I have to think about this. So you have f of x is the original, and actually h of x is the inverse. Okay? So if you want h prime at 1, I'm going to rewrite that because now we've been doing that inverse notation. Let's do that. So that really equals the inverse's derivative at 1, right? Okay? And that's 1 over the original not at 1. That's something else. All right. So remember, if the inverses has a point 1 something, then the original has the point something 1. And this is the y value on f. So here is f. Where is the y value 1? Do you see it? Let's go down this table. Where is the y value 1? These are the y's of f. Oh, there it is. Oops, there it is. Yes, I did that. Oh, I just going to cover that up. Sorry. So there it is. So that is my y. What x does it go with? That doesn't show up very well. Sorry, guys. So there's my y. It goes with 0. So that is the value that I want to put in there. So, wow, wish I knew f prime is 0. Oh, look, there's a column with f prime in it. So I'm going to erase this so it's not distracting. Let's go down to f prime and 0 and see where that kind of meets. And that meets at -1. So it's 1 over -1, which is -1. So this is a tabular way or a data way that you can actually do derivatives, and you don't know anything. You don't know the function. You have nothing. And look at all this stuff we didn't use. This was all distractor information. They wanted you just to go pick some of those numbers and throw them in your answer. So make sure that when you do these problems, you set up and tell them what, tell yourself what you want to look for, and just go look for that and find that in your table. The next one I want to look at is number 13, and that's because it's a trig function. I love trig functions. I love the unit circle. Isn't it great? So here we are again. Let's read this. Let the function be sine, and of course they had to put you on the restricted because we're going to talk about the inverse, and this is the restricted domain for the inverse function. And so it asks you for the value. G is the inverse. G is the inverse. So if they're asking you for g prime of 1/2, what they're really saying is, what is the inverse's derivative at 1/2, right? And the inverse's derivative at 1/2 is the reciprocal of the original function's derivative at something else, right? I don't know what that is. So let's do this again. I do this every time, and it really helps me. If the this is talking about the inverse. If the inverse has a point 1/2 something, then the original function has something 1/2. So when is sine x equal to 1/2? When is the y value, the y coordinate on the unit circle, equal to 1/2? Okay, so we got to know our unit circle, right? Woo! That's terrible. Sorry about that. So when I think about this, it's, there's three choices. There's pi 6, pi 4, and I know it's not that one because I know that's the same one that's root 2 over 2, and pi 3rds. And of these three, which one do you go up the least amount? Because this one goes out a long time and up a little bit, right? And this one goes out a little bit and up a lot. So it's the one that goes up just a little bit, so it's pi 6. You might just have those memorized, but if not, that's kind of how I remember it. Because if you had to choose between root 3 over 2 and 1/2, you know that root 3 is bigger than 1, so this is longer than 1/2. And you go up a little bit here, but you go up a lot there. So that's why I know it's the pi 6, not the pi 3rd. Very interesting, huh? All right. So I know that x is pi 6. Oh, sorry. You know what I didn't do? I didn't put my derivative right there. That's terrible. Please. Okay. Let's go back on that one. I hope I didn't say it wrong. So let me go back and say this again. The inverse's derivative at 1/2 is the reciprocal of the original function's derivative at, and we just figured out that was pi 6. So again, I wish I knew the derivative of the original function and I could plug in pi 6. Y'all, that's sine. That's not a big deal, right? So the derivative of sine is just cosine. Come on, we're not scared of this. We know our trig derivatives. We ain't scared. So if you put in pi 6, what is the cosine of pi 6? And that is square root of 3 over 2. Because that's that you went out way long and up just a little bit. That's your square root of 3 over 2. And so we're going to put that in there, and if we do, we're going to flip it just like we have the other ones, and we get 2 over root 3. Is that an answer? I think it is. No need to rationalize. We don't care anymore about having those square roots on the bottom. So I think that's it. Those are the problems I wanted to do for example for you. And so I hope that's helpful. So every time you see an inverse, this is what I want you to say. The inverse's derivative at whatever is the reciprocal of the original at something else. Think about that. And don't let that problem that tried to fool you by using the other derivative get you. So I hope this has been helpful, and I hope that you will go work the rest of the worksheet and talk to your friends and love the inverse function's derivative. Hope you had fun. I know I did. Thanks, and hopefully I'll see you soon. Bye.